ever seen videos like this?
Genetically modified foods create molecules that the body doesn't know. Genetically modified foods have the ability to tamper with your DNA. Genetically modified foods cause cancer.
Avoid GMOs in your diet?
I do. There's just a vibration with GMOs. For me personally, just something that I don't particularly want to put into my body.
What does GMO stand for?
Genetically modified. I don't know.
Really? Vibration? You don't even know what GMO stands for. I think my head hurts.
A few moments later.
If you've ever scrolled through TikTok or other social media apps, you've probably seen videos warning you that GMOs are dangerous, that they can cause cancer, or that they're unnatural, or should be avoided at all costs. But here's a question. Are GMOs really that bad? Or is this just another case of misinformation? Welcome to Splice of Life, your daily dose of biology. And today, we're tackling one of the biggest food controversies in the world, genetically modified organisms or GMOs. Before we start, let us define what GMOs are first. Genetically modified organisms or GMOs are living things or organisms that have had their DNA altered using genetic engineering. They may be plants, animals, or bacteria. This is different from traditional breeding, which takes generations to produce changes. With GMOs, scientists can directly insert specific genes into an organism's DNA to give it useful traits like pest resistance, longer shelf life, or even added nutrients. And believe it or not, humans have been modifying food for thousands of years now, way before we even knew what DNA was. Now that we know what GMOs are, let's revisit the timeline, shall we? In 10,000 BCE, early humans began selectively breeding plants and animals to get bigger, tastier, and more useful varieties to have more to eat. For example, we have wild corn or teosinte, which has tiny few kernels and is mostly inedible. Farmers kept replanting the biggest and best kernels and did hybridization, thereby eventually leading to the birth of the thick, juicy golden corn that we eat and turn into buckets of popcorn today. We now jump to the early 1950s, and scientists are desperate to crack the code of life. Here comes Miss Rosalind Franklin snapping the now famous photo 51 with X-ray diffraction. Meanwhile, James Watson and Francis Crick, using her data without her knowing, by the way, pieced together the iconic double helix structure in 1953. And boom, biology is forever changed. We now jump to 1973, where Stanley Cohen and Herbert Boyer discovered how to use restriction enzymes to cut DNA at specific points and insert new genes. This allowed scientists to transfer genes from one organism to another. By 1994, we got the first FDA-approved GMO food, the Flavor Saver Tomato by Calgene, genetically modified to stay fresh longer. And by 1995, GMO crops like BT corn or Bacillus thuringiensis corn were approved. Now, the market is saturated with many GMO crops, especially seedless fruits, apples that oxidize and brown more slowly than usual, and are heat-resistant. Now you may ask, how are GMOs made? Let's take BT corn as an example. First step is gene identification. So our scientists need a gene that makes corn resistant to pests. And the answer is Bacillus thuringiensis, which is a bacterium chilling inside our flower, moth, caterpillars, and soil. So this little guy produces a Cry1AB gene, which makes a 130 kDa protein that is deadly to corn borer's gut, but totally harmless to humans. So what do? We cut that gene and insert it into a plasmid. First, scientists take a plasmid, which is a circular piece of DNA from bacteria, and then snap it open with restriction enzymes. And then this makes room for the Cry1AB gene from Bacillus thuringiensis. Then DNA ligase swoops in and pastes everything together, and boom, we've got a recombinant plasmid. The recombinant plasmid is introduced into corn cells using gene guns or agrobacterium tumefactions, a bacteria that naturally transfers DNA into plants. These genetically modified corn cells are grown in a lab until they develop into full plants. These plants now contain the Bt gene and can naturally produce their own insecticide. This meant farmers no longer had to spray as many chemical pesticides, making Bt corn a safer and more sustainable option. In fact, it reduced pesticide use by 90%. This is helpful to farmers who had to spray pesticides up to 80 times per season. In fact, this is not the only advantage of GMOs, particularly food. For instance, in the Philippines, vitamin A deficiency is a major problem affecting many children. This leads to blindness and weakened immune systems. However, golden rice saves the day. Golden rice, which was developed by Phil Rice and IRRI, was genetically modified to produce beta-carotene, a precursor of vitamin A. It created a huge impact as one bowl of golden rice can provide 30 to 50% of a child's daily vitamin A needs, thereby resolving the issue. I'm sure some of you may still be skeptical about GMOs. The bottom line is, are GMOs safe? The answer is yes. Before approval, they go through years of testing by the FDA, Department of Agriculture, and global organizations like World Health Organization. But here's the catch. While GMOs themselves are safe, some companies exploit them, like how Bt corn was banned in Mexico for producing sterile seeds, forcing farmers to keep buying new ones. GMOs were meant to benefit everyone, but issues like this push us to rethink its sustainability. In conclusion, GMOs are not bad. They're simply advancements meant to eradicate hunger. However, we need ethical practices and maybe a few were internet myths. And that's all for today's episode. This is Splice of Life, your daily dose of biology. Goodbye!